Okay, we're going to go over and demonstrate how to do the problems from the review. So here we go. So problem number one, we got 3x minus 12y minus 2x squared plus 6y. So in order to simplify this, what we want to do is combine like terms. So we want to look for any terms that have the same variable part and combine those either through addition or subtraction. So in this case, we got a negative 12y. So this minus sign you would think about it, and when combining these two terms as a negative term, plus that 6y there, and those two would combine to equal a negative 6y. It is also most common for answers to be written with the largest exponent of the variables first. It's not a rule that is always has to be done that way, but it is the most common way. So the most common way this answer would be written is as negative 2x squared plus 3x minus 6y. Okay, looking at problem 2, this one is addition of polynomials. So when we're adding polynomials, the parentheses really don't have any effect on the answer. So what we just want to do here is really just combine like terms once again. So we got the 3x squared here, and we have a minus 7x squared there. So in order to combine those two terms, we need to know that's 3 minus 7 is a negative 4. And then those two terms would then combine to equal a negative 4x squared. Notice here that you do not change the exponent when combining like terms through addition or subtraction. Okay, and then we can look at this. We got this minus 4x here, and we got a 2x here. Now we're going to add because this is addition, so that's going to be negative 4 plus 2, which is a negative 2x. And then we also have an 8 plus minus a 5 that would combine to a plus 3. Okay. So that would be all that we would need to do for that one. Now, number 3, we are now subtracting two polynomials. There's the minus sign in between these two parentheses, indicating that this is a subtraction problem. Now, when subtracting two polynomials, before we can start combining like terms, we need to distribute this minus sign, which is going to have the exact same effect as multiplying that 7n plus 4n to the third by negative 1. So you multiply there, we want to multiply there, and then combine like terms. Now, so what I'm doing here is I'm just rewriting this first polynomial, and then the 7n will now become a minus 7n. The plus 4 into the third will become a minus 4 into the third. Okay, and from here, it is combining like terms, and as I said on problem number 1, we generally would want to write these terms in order of the largest exponent down to the smallest exponent. So the 3n squared, now there's not another n squared term in this problem, so it is going to be the middle term here, and then the 5n minus 7n would combine to be a negative 2n. So next we want to multiply polynomials. Okay, so number 4, we've got the negative 7 that we need to multiply by the 3m squared plus 4m plus 5. And that is going to mean we need to distribute the negative 7m. In other words, multiply it by each of those terms in the parentheses. So negative 7m times 3m to the second power is negative 21m to the third power. Negative 7m times a positive 4m is a negative 28m squared. And negative 7m times a positive 5 is a negative 35m. And that would be all we need to do on that problem there. Okay? Moving on to problem number 5. we have 2xy times y squared plus 4xy plus 2. So we want to distribute, and distribute. Okay, and so 2xy times y squared is, yes, 2x, well, it's actually 2xy to the third. 2xy times 4xy. So yeah, when you're doing this kind of multiplying, you really kind of want to multiply each piece individually. In other words, multiply the 2 times the 4 and get an 8. Multiply the x times the x and get an x. And the y times the y and get a y squared. Very good. And then 2xy times 2 is a positive 4xy. Okay? All right. And then for problem number 6, I'm going to demonstrate this using the distributive method. So I'm going to take the 2x and multiply it times the x, and then take that same 2x and multiply it by the negative 1. All right, so I am just going to use the distributive method to demonstrate how to do that problem. So 2x times x is 2x squared. Very good. 2x times negative 1 is a...
Wait.
That is right, yes. Okay, so that's 2x times a negative 1, which is a negative 2x. Then we want to move on to the plus 1 and distribute it. So we distribute both terms from the first parentheses by multiplying it by both terms in the second parentheses. So 1 times x is a positive 1x. And notice when you're doing this multiplying, you always want to make sure that you put a sign in between terms. So because positive 1 times positive x is a positive 1x, you'd make sure to put a plus 1x there. And then 1 times negative 1 is a negative 1. Just remember, you're multiplying at this step. There is a common error here of maybe adding those two terms and writing a 2 there as the last term, but 1 times negative 1 is a negative 1. From here, your middle terms are almost always going to be able to be combined. And in this case, they would combine to equal a negative 1x, because negative 2 plus 1 is negative 1. And so that would indicate that a negative 2x plus a 1x is a negative 1x. And that would be our answer for that problem. Okay, number 7, I'll go ahead and do the box method on number 7. The box method does work no matter how many terms you are multiplying. So in this case, a binomial times a binomial, but it would work with a trinomial times a trinomial, or even if you had 4 terms times 4 terms, it would work as well. You just extend your box, make your box bigger. So once we set up the box with the y plus 4 up the top and the y minus 4 along the side, then we want to go ahead and multiply to fill in the terms in the box. So y times y would be a y squared. Y times positive 4 is a positive 4y. Y times negative 4 is a negative 4y. And negative 4 times positive 4 is a negative 16. After multiplying, we want to take the terms inside of each of the boxes and write them out horizontally. So y squared plus 4y minus 4y minus 16. And once again, you see that those middle terms are able to be combined into one term. And in this case, they equal 0, which means I don't need to include that term in the final answer. And you'll see that this happens where those two middle terms cancel out anytime you're multiplying two binomials together where the only difference in the two binomials is that one is plus and the other one is minus. That indicates that you're going to have that situation where those middle two terms are going to be able to be canceled out. Okay? Number 8, let's do this one, distributive method. Okay, so 2x times 3x is 6x squared. 2x times negative 2y. So when I'm multiplying an x term times a y term, then those two would be multiplied together to just give me a xy term. In this case, it would be a negative 4xy because 2 times negative 2 is negative 4. And then the middle terms, or excuse me, that's distributing the 2x. Now, distributing the y, the positive y, into the 3x minus 2y would equal a positive 3xy. So normally you'll see that variables are written in the same order as they are in the alphabet. So we want to write the x before the y, even though we are multiplying the y times the 3x. And then y times negative 2y is a negative 4y squared. Okay, and once again, we see that those middle terms are like terms.
That last part, how did you get that from y times negative 2y? Wouldn't that just be 2y to the second power?
Yes. Yeah, sorry. Yes, because there's no, I'm not multiplying, sorry. So yes, so that would just be a minus 2y squared. Thank you very much. So you get 6x squared minus 1xy minus 2y squared. And of course, we never have to write a 1 in front of a variable term. We can always just write that with the, in this case, as the minus xy. I'm saying the first thing we want to do there is take this x plus 9 squared and write it as x plus 9 times x plus 9. Okay, so we don't want to try to multiply it out in the form that it's in. We really do want to write it as an x plus y times an x, or x plus 9 times an x plus 9. So here I'll go ahead and do the box method, just keep them going back and forth. So x plus 9 here, x plus 9 there. X times x is? X times 9 is a plus 9x. 9 times x is also a plus 9x. And then 9 times 9 is an 81. Now remember, again, here you are multiplying. So we're not adding 9 and 9. We are multiplying 9 and 9. Okay? From here, combining like terms, we would have x squared plus 9x plus 9x plus 81. And those two terms combine to equal an 18x. Yes. Okay. I've already moved.